So forgive me because I'm not a teacher, all right? I've just quickly knocked this up on a bit of wood. I had a contactor that was left over that I didn't end up using for a job, and all these are just bits I've got in the van, all right? So this would be a basic wired setup to power a shower. You'll have, this could be, now this contactor, depending on the brand, it could be mounted inside the consumer unit. If not, it could be mounted next to the consumer unit, or it can be mounted in the loft. Retrospectively, you could cut into the cable that feeds the shower and put a contactor up in the loft, and then just wire a pull cord perhaps to do this job here. So you'll have the supply in from perhaps the local lighting circuit or its own RCBO, label it up control circuit, and you've got a line, neutral, and a CPC. Now I put them on dim rail connectors because you know me, I'm extra. So I'll keep the CPC on its own dim rail terminal, right, on purpose for testing reasons, which is why I would always put. I've got the shower CPC on its own dim rail terminal and earth the dim rail there, and the CPC of the control circuit, I'm putting it on a non-CPC, a non-earth terminal, so we don't get funny readings when you're testing R1, R2 testing the shower or this control circuit. So you're live in from the consumer unit into a terminal. Now you could use a Wago if you want, or a connector block or whatever. I'm just using dim rail terminals. So live in, the neutral goes round to contactor terminal, the terminal A2 there, right? Now the 10mm or the 6mm or whatever the load is coming from the board is going to go in the supply terminals. And if you look at the diagram on this contactor, I'm going to use terminals 1 and 5. You can see there's the A1, A2 coil. When the coil is energized, it pulls, you see the diagram here, it pulls these contacts in, all three of them, and they clunk together, and it makes contact between terminal 1 and 2 make contact, 3 and 4 make contact, and 5 and 6 make contact between each other. So this can be used in a setup where you might want to control multiple lighting circuits from one control circuit, quite common in larger commercial lighting installs. But we're not bothered about that too much. We've got a 10mm or 6mm coming in. So this is coming straight from the B40 or whatever, or B32 or whatever you've got, whatever the load is, comes straight into the supply terminals up here. You've got a 6 amp RCBO, comes in, and you have a live and a neutral in A2. You then have, on the outgoing ways, you have the 10mm or 6mm, whatever the load is. Now that will go from these terminals here, 2 and 6. I've chosen 2 and 6. That will go straight to the shower. So straight under the stairs, chased up the wall, in trunking, or chased in the wall, up into the loft, directly down, chased behind the tiles, and then directly to the shower then, right? No isolator or anything like that. And the other cable for the control circuit is basically going to become a live and switch live. That's all it is. So now you can run that with this 10mm. So I've got the live, comes over to here, and then the switch live, as you can see, I've got a sleeved brown. I've got a sleeved blue here. So it comes back onto the A1 terminal of the contactor. You can see it's just a switch wire. This is just a switch. It's just a switch. It's not that complicated. Very straightforward, but I appreciate that some people need to see it wired up to learn how it works. So when you apply voltage across the coil, A1, the switch line, and A2 is the neutral, it'll energize the contacts, slam them in together, and it will link between these terminals and these terminals. So if I flick the switch, that went red. It's not, I had a few people comment saying, oh, who would want a big clunky sound of a contactor? They are so much more quieter now than they were. Back in the day when I started, big contactors used to definitely have great big clunks in and out. Whereas modern ones, I mean, this is a 4-pole, but you can get a 2-pole one. They don't make that much noise. Listen. I'd say that's about the same loudness as the light switch. So you flick the switch, and then that will energize the coils here, apply voltage here, and directly to the shower. I'll show you what that looks like. I probably should have put like a light or something on the end, but so something visually. Let's have a look. We've got supply coming in, 230 volts. There's nothing coming out because the contactor hasn't been energized. We've got a supply here, which is the control circuit, which goes to the switch. You can see just here, 230 volts here. Now, it's currently dead on the terminals 2 and 6, but when I flick the switch, the coil will be energized and slam the contacts together. And then we have 230 volts on the outgoing ways. I'll just flick the switch again to show you. The contactors come away and you're left with no volts. And so that means that you end up with just a light switch, right? Or a pull cord. You can have the pull cord bringing on the shower. Now you can retrospectively apply this. If you get the 10mm or the 6mm that's up in the loft just before it goes down in the wall to the shower, take it out and you can fit a nice big enclosure like this, a 2-pole 45 amp or 63 amp contactor, right? Put the supply in from the board in one end and then the load out to the shower. And then you pick up a supply from a local lighting circuit. Again, do the same as what I've done here, all right? You could just do it in Wagos. Live in, go to the pull cord, switch live back into A1, and then they've just got the lighting pull cord in the bathroom to bring on the shower. These are designed to switch heavy loads, and I know the 50 amp pull cord, they're also designed to switch on load. However, we've all been to them where they've been burnt out and we've had a call out to replace them because people end up just using them all the time, just on, off, on. They use them to turn the shower off and on all the time, and it's a mechanical switch and eventually it fails. I've never had in 18 years one of these contactors, shower contactors that I've fitted, fail. Always keep the CPC separate for testing. So when you R1R2 the contactor circuit, you're not getting a parallel path to the shower circuit when you properly perform an R1R2 test. So you just put them in Wagos if you want to. And that is how a basic shower control circuit with a contactor would work. Now you can even do this via Kinetic transmitter and receiver, so it's even less wires, right? I've just wired up a Kinetic controller transmitter, right? Just a standard one. I'll turn the power on. Right, so I've got a Kinetic grid switch, right? You can get them to fit a few different brands at the moment. And all you do is from a local lighting circuit, you supply the Kinetic transmitter, okay, from anywhere. I mean, you could even do it via a fuse connection unit off of the ring circuit and obviously fuse it down appropriately. Supply the receiver, and then the outgoing leg, so the outgoing way, the switch line and neutral, you wire that into terminal A1 and the neutral into A2. If I put this into pairing mode, press and hold for so many seconds until it starts flashing. There we go. Get this out. I've just got to click one because I've got it floating around. Connect. That should be connected now. So when I press this, we should then get mains on our shower via the contactor. So, look. There you go. So then I can place this anywhere, in the shower, in the bathroom if you wanted to, depending on your setup, of course. And then you've got the contactor controlled via the Kinetic transmitter, and you've got it running that way round, rather than struggling and trying to use a big old pull cord, which we all know, we all get call outs to them. It's a mechanical switch which eventually breaks down. This is designed to do that. I know the pull cord is also designed to do that, but we know In 18 years, I've not had a shower contactor callback or one of these fail. So the output of this arrangement, so in the outgoing, live out and neutral out, the live out goes into the contactor terminal A1 and the neutral goes into A2. I just think this is a quick, long-term solution, right? Doing it this way around. And it doesn't cost that much more money. The price of a contactor, the price of an adaptable box, and a Kinetic transmitter and a switch is all it is to never get a callback for a burnt out shower isolator ever again. Surely you agree with me. That is simpler, easier. It's slightly more expensive than your traditional shower install, but you'll never get a callback. I've only done this arrangement maybe once with the Kinetic. I've wired it, hardwired in it for many years. It's only when I can't convince the client to go for a wet shower off of the boiler. If they really, really, really want to do electric shower, or if it's the only way, perhaps they haven't got any gas at the property and they need to electric. This is a fantastic method. Even wiring it doesn't cost that much more money either. And some people said to me that, oh, they won't want a great big clunk every time they turn the shower on. I think the sound of this is no louder than a traditional light switch. That isn't that loud. And if you put the cover on that, or that's inside your consumer unit, or up in the loft in the adaptable box with the lid on, there's no extra noise there.